this is kind of something I follow every single time I do a problem of what we're doing today. The null hypothesis is either true or the null hypothesis is false. Those are two options. This is, at this point, this is kind of like tossing the hoop into a pitch black room. We don't actually know which one is true, and we might never know. But just like theoretically, after that toss the hoop into a pitch black room, either it did what it was supposed to or it didn't. So at the very end, I always decide to do something with my null hypothesis. I only have two options of what I can do with the null hypothesis. Either what or what? Reject or fail to reject. So we're just going through scenarios here. Regardless of what happens, I can end up rejecting the null hypothesis, or I can end up failing to reject. So even if it went this way, I could have made the decision to reject the null hypothesis or fail to reject. So those are just writing out all of our possible scenarios. All right, now, if our null hypothesis were true, again, I probably will never know if it was or wasn't, but if it was true, what should I have done? If it were true, what should I have done? Fail to reject it. I don't want to say it's wrong if it wasn't. So that path would have been I did the correct thing. If our null hypothesis is false, what should I have done? Reject it. So those are like the paths that if I did the right thing. Now, I always make the decision to reject or fail to reject based off of a sample. Everybody gets that, right? Does that mean my sample is perfectly representative of my population? No. So I could happen to get a bad sample that told me something that was not the truth. Let's say there's 100 pennies in a bucket and one of them is a dime. 99 pennies in a dime. If I get that dime and I'm only taking a sample size of 5, my mean is going to look a whole lot different than the population mean, right? Is that or let's say 99 pennies and something that's worth $1, but the same size, theoretically. If I happen to get that one that's worth $1 in my sample, and I'm only taking a sample of 5, my mean is going to be a lot higher than is representative of the population. Yes? So I can get a bad sample, and my sample tells me to do the wrong thing. I'll just never know that. So these paths are that something went wrong and I made a mistake. So these are errors. And we have to talk about our different possible errors. There is a type 1 error and a type 2 error. And the reason I use to remember which is which is not the reason it's called this, but it's the way I help myself remember. If the null hypothesis is true, does that sound like something's wrong? Which sounds like something's wrong? The null hypothesis was true or it was false? False, right? So this one doesn't look like something is wrong, but did I do something wrong if I rejected it? So in this path, how many things were wrong? Just one. Well, here, this is wrong because it's false, and then I did the wrong thing, so how many things were wrong here? So that's how I remember which one's which, but that's not the reason why it's called that. So this one is a type 1 error. This one is a type 2 error. So now I'm going to talk through some hypothetical situations real quick to get the whole picture, and then start working into specific examples from this. So last year, we came up on this topic right when Corona stuff was really starting to get in the news, with like decisions having to be made. And at that point, almost everything was unknown. So one of the big things was they were trying to decide if they were going to shut down the ports in California. So I don't need you to write this one with me. I just need to write it so that I can think through it. So null hypothesis is like, we're going to say do nothing. And then let's say the alternative hypothesis is to close the ports. And we're trying to decide, should we close the ports or should we not? Do we have evidence that it's worth it to close the ports or not? So we don't have a clue at that point in time if we really should or shouldn't, because it's the unknown that is coming ahead. And especially at that point, we literally had no idea what was coming. So let's think through those as errors. So let's say it was true that we should have left the ports open. So if we should have left the ports open, but we rejected the null hypothesis, that means we should have left them open, but we closed them. So a type 1 error here would be just kind of thinking through this. So what would a type 2 error be here? Should have closed them. So here, if we should have left them open, but we closed them, what is the backlash that's going to occur? So this is outside of statistics. This is just thinking real world. We've got all these ports in California with trade and all this stuff. We should have left them open, but we chose to close them. Money-wise is going to fall a lot because we thought we were doing something to save something with health reasons. Type 2 error, what would be our backlash here? Health reasons. So bring over this coronavirus, but don't lose money. And at the time, we had no idea what we were getting into. Now that we understand everything at that time, which probably would have been worse, losing money or bringing it in and spreading it? Probably this one. But at the time, this is a good example because at the time, we didn't know which one was worse or what was the right decision. So when we're making decisions, we have to think about both of these because it's always possible to make errors. So you have to consider both of your errors on each end and which one, like in different scenarios, one's worse than the other one. Something like death penalty. If the null hypothesis is that they're innocent and the alternative is that they are guilty, a type 1 error would be what in that situation with the death penalty? What? So the null hypothesis is that the person's what? Innocent, but what did we decide to do? Death penalty. What's my backlash consequence here? We put someone to death who didn't do what we charged them. Over here, what would have been what's the scenario of our type 2 error? They're guilty, but we let them go. What's the backlash there? Depending on what he did, right? Which one of those is probably worse? This one. So context is going to depend on which one's worse than the other one. So with this, I need to connect probabilities. So this path is called a type 1 error. This path is called a type 2 error. There's one other one that has a name for it. And I like to think of it as like the ideal path. If we're taking the time to the idea of take someone to court, what is the ideal path if we think we should take them to court? Of those 4 paths.
They're guilty and prove it.
They're guilty and we prove it. So this one right here is kind of what I think of as like the reason for doing it in the first place. And this is called power. And now there have been years where we didn't stress that word that much and people were fine and it probably didn't hurt them at all in the AP exam. And then there was one year, 3 years ago, and I can pretty much guarantee that there's one person in my class who passed the AP exam because they knew the word power. Because it was a major part of one of the free response questions, and she knew that term, and I don't know that she would have passed without it. So I think they're starting to stress this a little bit more than they have in the past. So you need to know the names of the paths. Now, probability is associated with each one of these. The probability of a type 1 error is alpha, which we've already talked about before. So you need to write this as your next part of this term. So probability of a type 1 error is alpha. We can set alpha at the beginning of a test, right? Like usually it gives it to us, if not we use what? 0.05. So if this case of a type 1 error is very severe, what kind of alpha do we want? So like if this is putting someone to the death penalty that was innocent, we would probably want what kind of alpha there? A low one or a high one? Would we want to make that kind of error? No, so probably that kind of error we would want low, yeah. So this one, and this is a symbol we have not talked about, is beta. Type 2 error, probability of type 2 error is beta. And now I need you to understand that if I say what is alpha, or what probability of a type 1 error is what, and you know alpha, and I say probability of a type 2 error is what, and that's beta. Well, this is alpha. Alpha comes first, beta comes second. Type 1 error, type 2 error. Also, this path, so if I go down this path, so like if I have a 60% chance of going down here, what chance would I have of going this way? 40. Well, how did you figure that out? Math. Right there. 1 minus. Which means what's our probability of power? So I already started on this path. Probability that went this way is beta, so it's probability I go this way. And I'm going to talk more about those as we go along, but I need you to understand that probability of type 1 error is alpha, probability of type 2 error is beta. If, what? Which I kind of think about that one as like the pointless. So we don't really deal with that, right? If I want, so I think about power as ideal scenario, and this is the part that I'm going to talk about more as we go. If I talk about power as the ideal scenario, and I want to make my ideal scenario very likely, what do I have to give up a little bit? So if I want my probability or my power to be really high, that means that what is going to be really low? Beta, a type 2 error. And I'm going to make those connections with But you understand that those are opposite, so as one goes up, the other one goes down. But I'm gonna add in stuff with that later as we go along. All right, so let's look at an example. So I want you to writing type 1 and 2 errors. And I want you to think about it as answering these 3 questions in this order. And I am going very slow today on this on purpose because people do get confused. So what did we decide? Well, I guess I should, what did the data decide? I usually say that as we, because like we do it as like we're the ones who ran the data. What was actually true? What are the consequences of that mistake? All right, so I'm gonna think of an example problem that's basic but has enough that we can do context with. The COLA one that I did yesterday in class, number 4, that we just did it for the math part of it. I think that was making sure it was filled appropriately. I'm going to use one like that, but I'm going to change it up a little bit. So let's say I'm going to do the idea, we'll do it with a 2 liter. So they're claiming that there's 2 liters of cola in a 2 liter bottle. Let's say we're going to test a specific direction. Let's say we don't think we're getting our money's worth and we think it's less than. So it's the idea of how much is being filled into a 2 liter cola. And we think that they aren't giving us the right amount. So I always kind of go through and do my null hypothesis true, my null hypothesis false. And some of y'all can do with that, like even still if I do a problem, I just write this off to the side. Reject the null hypothesis, fail to reject. That one's good, that one's good. So here's my type 1. This is my type 2. So my null hypothesis is true. This is where I think people get mixed up, is I like to start it with what did the data decide. So if it is a type 1 error, we decided to do what? If it is a type 1 error, we decided to do what? To reject. And if we reject it because we're saying that there's what? In this direction, right? So the data showed what in context? And I'm shorthanding my wording a little bit here so we can get the point. The data showed that there's less than 2 liters per cola per bottle. Everybody's with me there? So this is where people can go wrong. I don't need to write when there actually is exactly 2 liters. I can just say when that's not true. Because technically, if I'm doing it with here, what's the opposite of this? What's the opposite of less than? Greater than or equal to, which is kind of the way we think about this. Like we don't find, okay, that they were completely exactly right. That just means this direction is wrong. So the data show that there's less than 2 liters per cola per bottle when that's not actually the case. Or we'll just say when there is enough. So if we went to the company and said, here's our data, this is what we just showed. So like we're like a third party company or something. We said, we took a sample, your sample shows that things aren't looking good, you're not filling enough. What does the company now have to go do? If I'm working for them as like a third party and I tell them it's wrong, what are they probably going to do? So they're going to compensate for it. So the company makes adjustments. To fill more, which means what? As a consequence. What's the consequence to that company? They're losing money and spends money unnecessarily.
How do you decide which one is actually true? Isn't that what we're supposed to do?
We'll never know if we made a mistake or not. So we're theoretically saying, because I'll never know if I made a mistake or not, I have to consider both of my issues to be able to talk about it. And so that's the whole of throw it in the pitch black room. We'll never know if we made a mistake or not. Yes, these are my first 2 questions right here. Alright, so then a type 2 error I'm gonna write on that same sheet. So type 2 error would be the data showed what? So think about it in context here. Okay, so data showed that there was enough in each bottle. Like that, or like saying there was at least 2 liters?
Saying that there was 2 liters.
That's where I try to avoid it because it can be more than and still be fine.
Okay.
So I'm kind of well, let me finish writing, then I'll answer what you're asking a good question though. So data showed that there was enough in each bottle, but actually what? More specific. So I do it to where I only directly say the direction of the alternative once within each problem, and then try not to talk about specific directions other than that so I don't get confused. And I've done it both ways before, but this is usually the less confusing for people. So yes, I can talk about it as exactly 2 liters. Yes, I can talk about it as greater than or equal to, but I only talk about the direction of the alternative. Here, the direction of the alternative should be what we found. Here, the direction of the alternative is what was actually true. With me there? So now here, what would the backlash consequence be? what, and this is kind of, we're just thinking of it. Let's go with, so consumers not getting what they're paying for. In this situation, and so a lot of times the consequences, I'll ask like which one is worse. It depends on who you're asking about. So which one would be worse for the company here? This one because they're losing money. Which one would be worse for the consumer? This one?
Well, like, why aren't they the same? Why aren't the results the same?
The results are, these are saying theoretically if my data were wrong.
Why aren't the consequences the same?
Because it's two different errors.
But like, you're getting the same result. Like you're,
Okay,
I don't know.
okay, I see what you're saying. So pretend I took a sample, I took one sample and I got a result and I made this error.
Okay.
End of scenario. Somebody else went out, they took a sample, their sample was bad, and theirs happened to be this way. It's not that one sample is bad in both directions.
But like,
So you took a sample and you got, in your sample, you just happened to get the ones that were filled really high. So you went with this one. And my sample happened to be the lowest ones they got that day, and mine ended up going with the others. Error.
but like, why don't, how do they know who to believe them?
They don't, and you'll never know that you made an error.
Well, then why can't I put for the second one the same thing as the first one? Because
It's
like,
different.
if they think it's low, they can, you know what I mean? Like if I say it's low,
But this is a different thing. This one
but
says,
it's the same.
oh, not. This one's, the data, it says it's low, but it wasn't. This one's, the data says it didn't, but it was.
But they don't, oh. So there's only one set of data, not two?
Yeah.
Okay.
But both of these aren't gonna happen at the same time.
Okay, that makes sense.
Yeah, we're just thinking, we have to think theoretically when we're thinking of errors. Alright, so my last scenario, and I'm gonna put this as a separate video because this is gonna be your homework.